Momentum and impulse topic test. Let's take a look and see what is going on. So, question 1, multiple choice questions. Let's see how we approach this kind of questions. 1.1, which one of the following best describes an inelastic collision? So, before we even look at our options, A, B, C, and D, we know that a collision is deemed inelastic when momentum is conserved, but kinetic energy is not. So that's what we are looking for essentially in our options A, B, C, and D. Option A, both momentum and kinetic energy are conserved. That would be an elastic collision, not an inelastic collision. So A cannot be our answer. B, total kinetic energy is not conserved, but total linear momentum is conserved. We need to look no further. The correct answer to 1.1 is B. 1.2, in the equation F net multiplied by delta T is equals to delta P, the product of F net delta T represents the impulse, right? We know that from theory. There's nothing we are calculating here. There's nothing we need to figure out. We just taking our answer as it is. So 1.2, the answer is C. F net delta T is the impulse. There's really no need for an explanation here because that is just theory, okay? But things get interesting when we go to 1.3 and 1.4. Take a look at 1.3. So a body is moving at a constant velocity and has kinetic energy E and momentum P. The velocity of the object is doubled. Which one of the following correctly gives the magnitudes of both the kinetic energy and momentum? Right, so it has the velocity v initially, and it is then changed to 2v. So the momentum when the velocity is v will be p is equals to mv. And then the kinetic energy when the velocity is v will be a half mv squared. Let's take a look at the scenario where the velocity is now 2v. The momentum will be p is equals to, let me say, px, right? Px will be equals to m multiplied by 2v, which is equals to 2mv. So this is 2p. So the momentum doubles when the velocity doubles. Now let's take a look at kx. We're gonna have a half m instead of v. We have 2v, and we square that. This is gonna be equals to a half m multiplied by 4v squared. This is equals to 4, right, multiplied by a half mv squared. We know fully well that a half mv squared is just k. So kx, the new kinetic energy, is 4 times the initial, and the momentum is 2 times the initial. So which option gives us that? So option A, we have 2e, 2p. Our answer is option C, where we have 4e and 2p. So the answer to 1.3 is C. So there we go. This is how we solve these kind of questions. We're going to use the same technique or something close in 1.4. So 1.4 says a ball of mass m strikes a wall perpendicularly at a speed 2v. Immediately after the collision, the ball moves in the opposite direction at a speed v, as shown in the diagram below. The magnitude of the impulse of the ball is. So impulse is equals to the change in momentum, right? But it is also equals to F net delta T. So we're going to have m vf minus vi. So m is just m, and then let's talk about v. It strikes the wall with a velocity of 2v, and then it leaves the wall with a velocity of v. But if you look at the direction, this is to the right and that is to the left. So we need to think about that when we substitute. So which direction do we need to take as positive, and which direction is going to be negative here? If we take direction to the right as positive, we'd have 2v minus v, which will be plus, right? So this is going to give us 3mv, which is option D. That is 1.4. We need to be comfortable with working with variables. If you like this video, you will definitely love my course. Go ahead and click the link on my bio and you will land on this page. You will not only find the past exam questions, but introduction videos where I break down complex concepts into small pieces that are easy to digest. It is very important in grade 12 to stay ahead of your teacher, and this is what this course is for. It's very easy to navigate through the course as videos are arranged into collections. You can clearly see that we have electrostatics, work energy and power, Doppler effect, so on and so on. Do you maybe need help with study tips and creating your own timetable? We can talk about that inside the course and I can help you out. It doesn't even take a minute to join. Can't wait to hear from you.